I'm looking at a slightly different one here. This one I think is a little bit more difficult, so I'm choosing this one to do for the video. Um, Before we look at the algebra here, let's kind of give a general idea of what we're doing. So we've got this function, f of x. It's a rational function. And what they're asking is not what would you get if you plugged 3 in for x. What they're asking is what x would you need to get 3 to come out. So we want to know what would we have to put in for x to get 3 as the outcome for our function. We could look at a graph. In fact, it says find the points on the graph, but so we can look at the graph. I've got it graphed here. And again, we're not asking when x is 3, what is y? They're saying if the function at 3, or the function has the value of 3, or y is 3, what x will give us that? So one of them is right there, 2, 3. One of the answers, done, 2, 3. When x is 2, y is 3. The function has a value of 3 when x is 2. There's another one over here, because that line at 3 crosses the graph twice. I can't quite get it right on 3, and so it's got to be some fraction or some irrational number, one or the other. It's going to be right in there. So that's harder to see just on the graph. And that's why we're going to use some algebra. So I've copied this down onto a piece of paper. I'm going to use a document camera here. All right, so here is our function. We want to know what x will give us the value of 3 as an output. So I'm just going to substitute. I'm going to replace f of x here with 3. So we get 3 equals 8 minus x over x squared minus 7x plus 12. There we go. Now, I'm going to write a slightly different, much smaller equation over here. If I had 3 equals x over 5, so I just made this up, has nothing to do with this stuff over here. If I wanted to solve this, one thing I could do is I could say, well, the opposite of divided by 5 is times 5. So I can use the inverse operation. 5 divided by 5 is 1. So we have 1x left over on the right side. 5 times 3 is 15. There's my solution. 15 divided by 5 equals 3. Yep, it checks out. So to undo divided by 5, we could use the inverse operation, multiply both sides by 5. I can do the same thing over here. It's a bigger problem, but the same operation works. This is divided by some big giant polynomial here. But there's nothing to stop me from multiplying both sides by whatever this is. I'm just going to multiply both sides by x squared minus 7x plus 12. And the result will be the same as over here. Anything divided by itself is just 1. So I'm left with 8 minus x on the right side of that equation. If I multiply the left by the same thing, so I have to keep that balance, minus 7x plus 12. Go. I'm going to have, well, x squared minus 7x plus 12 times 3. From there I can distribute. So I can distribute the 3 through the parentheses. I'm going to speed up a little bit here. Minus 21x plus 12 equal, not 12. 3x squared plus or minus 21x plus 36. Don't go too fast, I guess. To solve a quadratic equation like this, it's often easiest to make it equal 0. It's not the only way, but it's typically easier to make it 0. So if I wanted to get this to equal 0, I could add x to this side. So I'd have minus 20x. I could subtract 8 from both sides. I would get, plus 28 equals 0. So I added x, I subtracted 8. So there's 3x squared. All right, we could use the quadratic formula. You could complete the square. I'm going to factor just because it's certainly not the only way, but I'm going to factor. And if I do that, let's say it's kind of like the AC method, which is fine. If you use the AC method, that's great. I'm going to use a slightly different one. This is my preferred method. I'm going to ignore the middle number. I'm going to find two numbers that multiply to 3. I find two numbers that multiply to 28. Probably should have had this ready ahead of time. Let's go with 14 and 2. I think 14 times 2 is 28. And then I'm going to do what I call the rainbow, taste the rainbow. 3 times 2 is 6. 1 times 14 is 14. If I pick the right numbers, this could have been 7 and 4. But if I pick the right numbers, this should add up to my middle number here. I'm close. That's a minus 20. This is a positive 20. If I do this, negative times a negative is a positive. Negative 6 plus negative 14. There it is, negative 20. All right, I've got the right numbers. Told you this one was harder than the other one. Now I'm going to fill in the blanks for my factors. So this becomes 3x. And that's a minus 2. Minus 14 and x. That is not the best, nor is it the only way to factor a polynomial like this. So if you have a different method, great. AC method, I know was covered in this class. That's a great method. And this is the method that I choose. We're still not done. We still haven't finished the problem. The zero product property says that, I'm going to rewrite this because it's so messy, says that if you have two things multiplied together, which is what we have, the product of two things, and it equals 0, one of them has to be 0. 0 times something equals 0. Something times 0 equals 0. One of these two has to be 0. To make this 0, 2 minus 2 would be 0. So if x equal 2, 2 minus 2 would be 0. 0 times anything would equal 0. We have a solution. What would make this x? Well, we could solve it. I guess I can do that. I'll do it. I'm running out of room here. Maybe I'll do it over here. 3x minus 14 equals 0. If you could do it in your head, great. It ends up being 14 thirds. But you could solve this for x. You could add 14 to both sides and then divide by 3. And you're going to see that that's my solution that I got here. So those are the two values of x. We know what the value of y is going to be. It's going to be 3 because that was the point. The point was to figure out what would give us a value of 3. So when x is 2, y is 3, and we saw that on the graph. When x is 14 thirds, y is 3, and that's why I couldn't quite get there on the graph. So all this gobbledygook here that I've done, the final answer would be 2, 3, or 14 thirds, 3. Those are the two different solutions for that problem. Lots of work, but that's how it's done.